Good morning, chemists. Today we will be looking at periodicity. So sit back, relax, and enjoy as we dive right into it. Hopefully you learned something new, and if I missed any facts you think are important, please feel free to share them in the comments. Let's begin by defining periodicity. Periodicity refers to the trends found on the periodic table. Periodicity consists of three sections: atomic radius, ionization energy, and electronegativity. There is also melting and boiling points, but we will not be discussing that today. Here are a couple diagrams for you guys to look at. And for now, let's jump straight into it. The first trend that we will be looking at today is atomic radius. Atomic radius is defined as half of the distance between two nuclei of two identical atoms bonded together. The reason why we use two atoms is because the position of the outer electron cannot be determined. Atomic radius decreases from left to right and increases from top to bottom. From left to right, atomic number will increase, and therefore the number of protons will increase. This causes an increase in the effective nuclear charge of the nucleus. The nucleus is now more positive, and therefore electrons are attracted closer to the nucleus, resulting in a smaller radius. From top to bottom, electroshielding will occur. This weakens the effective nuclear charge on the outer shells of the atom. Attraction is weaker, and thus the radius is larger. An analogy we can use for this section is that the media view being fat as negative. So the more electron shells that an atom has, the bigger the atom will be. So here we have some extra information and a couple cool diagrams to help you guys out. If you feel the need to take in this information, feel free to pause the video. But for now, let's move on. The next section we'll be looking at is ionization energy. Ionization energy is defined as the amount of energy required to remove an electron from an atom or ion. Every electron has a specific ionization energy. First ionization energy is defined as the amount of energy required to remove the first electron from the outermost shell of a neutral atom, i.e. increases from left to right and decreases from top to bottom. You can see this in the graph above. As you get closer to the nucleus, i.e. increases. This is because the electrons are attracted closer to the positive nucleus and therefore require more energy to remove them. A cute little analogy that we can use for this is, the more a mother loves her child, the more difficult it will be to separate the two of them. Similarly, the greater the effective nuclear charge of the atom, the more energy will be required to remove an electron. Continuing with ionization energy, there are three factors that influence it: the charge of the nucleus, the size of the atom, and electron shielding. The charge of the nucleus. With a higher charge, the electrostatic forces of attraction between the nucleus and electrons is greater, thus more energy is required to separate them. The size of the atom. The greater the spaces between the nucleus and electrons, the smaller the ionization energy. As distance increases, ionization energy decreases drastically. Electron shielding. Electron shielding causes IE to be lower, as the positive charge of the nucleus is weakened, and thus less energy is required to remove an electron. You can see better and more concise explanations on your screen of all three factors. Now, moving on to the third and final periodic trend, electronegativity. Electronegativity is a periodic trend that describes the tendency of an atom to attract a bonding pair of electrons towards itself. For electronegativity, the Pauling scale is used. More information on that later. Two important things to remember when considering electronegativity is: number one, noble gases have no electronegativity, as they have a full outer energy level and are stable. Number two, electronegativity plays a big role in chemical bonding, and it increases from left to right and decreases from top to bottom. A simple analogy to remember this is that the more famous you are, the more haters you attract. Similarly, the more positive the nucleus, the greater the electronegativity. As we can see, electronegativity has the inverse trend to atomic radius. From left to right, electronegativity increases. As we have established, atomic radius decreases from left to right. This causes the effective nuclear charge to be stronger and thus better at attracting a bonding pair of electrons. From top to bottom, electronegativity decreases. Atomic radius now increases, and the valency electrons are further away from the positively charged nucleus. This causes a weaker effective nuclear charge on other electrons, and thus a lower electronegativity. Now, back to the Pauling scale. This is more extra information, so it's just good to know, rather than compulsory. The Pauling scale. Linus Pauling invented the Pauling scale. He gave fluorine, the most electronegative atom, a value of 4. The values of the other elements were given as comparative values, and thus electronegative values don't actually have units. And now finally, here is a quick wrap-up of everything we've hopefully learned today. Remember, chemists, atomic radius can be used to describe certain behaviors in compounds. Ionization energy tells us how reactive an element is, and electronegativity can tell us how an element will bond. All of this is important information to remember and understand to help us grow into better chemists. Thank you guys all so much for watching. If you enjoyed the video, please make sure to give it a thumbs up and subscribe if you're new around here. It helps the channel out a lot. And I'll see you chemists in the next video.